All right, so there's Rihanna. Do you guys know what Rihanna is? She sponsored this event, so she paid us money. No, she didn't. She didn't give us anything. I just put that in here. So yeah. All right, guys. So let's put the laptops away for now, guys, please, so we can focus on this. So this is related. You're going to be doing the same math that NASA does. The only difference between this and NASA is that NASA is four-dimensional. What do I mean by four dimensions? X, Y, Z, and time. And we're just doing it in two dimensions, a variable and time. So that's the only difference between a NASA engineer and you, plus the programming and all that other stuff, right? So let's see if we can do this. It's like implicit differentiation. There's a few rules that you got to know. You got to know a few. What do you got to know? You got to know a few area formulas, a few volume formulas, the basic ones. So let's look at example 1. Assume that the radius r of a sphere is the differentiable function of t, and let v be the volume of the sphere. Find an equation that relates dv dt and dr dt. Do you know volume of a sphere? Okay. Volume of a sphere is?
I know there's a pi in there. There's r. Square.
4/3 pi r cubed. That's volume of a sphere. Cool or not cool? I would, yeah.
Wait, is there like a formula sheet on the calculus exam?
There is no formula sheets. There's,
Not a single one?
no,
Not even.
not a single one. The hardest part of calculus is coming up with models. Calculus exam does give you the models, so you don't have to come up with the models yourself. But in my class, we're probably going to have to come up with the models. Like that. Like come up with the equation of what to differentiate. So it says, assume that the radius r, oh, I already read that. So how do I find dv dt, dr dt? Well, look, there's my big hint, the t. So I'm going to be taking a derivative with respect to time. So you're going to write dv dt is equal to 4/3 times 3 is 4. So I'm going to write 4 pi r squared. But I took that derivative with respect to time. So what do I write next to it? Yep. And that's it. You're done. Does that make sense? And there it is. My dv dt is related to dr dt. Yes. Yes, I go 3 times 4/3. The 3's cancel out. Pi r, and I subtract the 1 from the cube, and then I put dr dt. All right, here we go. Letter B. Assume that the radius r and height h of a cone are differentiable functions of t, and let v be the volume of a cone. Find the equation that relates dv dt, dr dt, and dh dt. Do we know volume of a cone? Volume of a cone is 1/3 pi r squared h. Cool? Sometimes, if you were to Google it, maybe it'll say pi over 3. I don't know. I didn't Google it. I haven't Googled it recently. So I don't know what Google says. It might have the pi over 3 r squared h. All right, let's take a derivative. We're taking the respect to t. So I would do this, dv dt, and you can group the 1/3 with the pi, but the 1/3 and pi are all constants, right? So I'm just going to leave that out. 1/3 pi bracket, and then I'm going to go first, r squared, times the derivative of the second, dh dt, plus second, h, times the derivative of the first, 2r dr dt. And that's it. I would leave it alone. Does that make sense? Right? What happened?
No, I'm walking through in my brain. Like over 8? Yeah.
Right. Here we go. Example 2. So now look, this is coming from excerpt from UH. Let's see if we can do it. A spherical snowball is melting in such a manner that its radius is changing at a constant rate decreasing from 21 centimeters to 10 centimeters in 30 minutes. At what rate is the volume of the snowball changing at the instant the radius is 3 centimeters? Okay, we have a sphere, a snowball shaped as a sphere. I'll try to draw a sphere there. I don't know if you can tell. The radius is what? I'm going to put R. So R is 3. Do not put the R equals 3 down here because then you're making it static. The R is changing. So I'm just going to write R. Oh. And then my dRdt, I got to find that. They told me that I'm going from 21 centimeters to 10 centimeters. So that means, what's that? So negative 11 over 30. And this is in centimeters per minute. Does everyone know how I got that? No? Okay. I decreased by 11 in 30 minutes. Are we still okay? All right, we're ready, guys. We already said that my dVdt was 4 pi r squared dRdt. And I don't know why it's coming out all wiggly like that. Are we still okay? So we're going to plug in what for r? 3. And we're going to plug in what for dRdt? Negative 11 over 30. So dVdt is equal to 4 pi times 3 squared times negative 11 over 30. So let's see what that is. I'm not going to put the pi in there, guys. I'm just going to go ahead and put 4 times 3 squared times negative 11 over 30. So I'm going to take out my calculator. Is that a bird or is that a swing or bird? It's a crow. It sounds like a swing that has rust on it, and one of the whatever. All right, I already forgot. What was that multiplying? 4 times. Yeah, I'm not gonna put the pi in there. Times 3 squared times. Negative 66 pi over 5. So dVdt is negative 66 pi over 5, and I need units. What type of centimeters? Cubic centimeters per minute. And if you look at your stuff that you're multiplying, it is going to come out to cubic centimeters per minute. This is radius in centimeters, so when you square it, that's square centimeters, and this is centimeters per minute. So centimeter times another centimeter is cubic. Centimeter squared times centimeter is cubic centimeters, right? Okay. Does everyone know what we mean when we say a cubic meter or a cubic foot? No? Okay. I want you to visualize it. Do we have a ruler? I see a ruler right there. When we say a cubic foot, everyone knows what a ruler is, right? When we say a cubic foot, you are literally looking at a box that is 12 by 12 by 12. That's all it means. So if someone says this takes up 5 cubic feet, it takes up like 5 boxes that are a foot by a foot by a foot. Does that make sense? Like pretend we have a box. I don't know, this might be a cubic feet. Okay, it's close. Not quite. This is probably like, pretend that was 12 inches across, 12 inches like this, and 12 inches up and down. This would be 1 cubic foot. Does that make sense? So when we're talking about how much depth something covers, that's where you use the cubic. How much volume is in this pool? 4 Sorry. Hey, bird. It's like, to me, it sounds like a swing. But okay, check it out, guys. This is why related rates are so useful. Look at this question. A police cruiser approaching a right-angled intersection from the north is chasing a speeding car that has turned the corner and is now moving straight east. So north, south, east, west. When the cruiser is 0.6 miles north of the intersection and the car is 0.8 miles to the east, the police determine with radar that the distance between them and the car is increasing at 20 miles per hour. If the cruiser is moving at 60 miles per hour at the instant of measurement, what is the speed of the car? So we want to know the speed of the bad guy. How do we do it? We'll start with drawing. So here we go. Ready, guys? No, don't worry. You're probably going to get it right. But look, start with a model. So here we go. Here's my right-angled intersection. Here's the cruiser, or I don't know, what do you want to call the cop car in that black dot. Here's the bad guy in the blue dot. And I know that this guy, the cruiser, when the cruiser is 0.6 miles, okay, so I'm going to call this Y. I'm going to call this distance Y. I'm going to call this distance X. Are we okay with that? Okay. When the cruiser is 6 miles north of the intersection, so Y is 0.6 miles. And the car is 0.8 miles to the east, so X is 0.8. Oh, they're being nice to us. The police determined with radar that the distance between them and the car is increasing at 20 miles per hour. Okay, what distance? This distance. This is a right-angled intersection. That distance, I'm going to call that Z. So determine with radar that the distance between them and the car is increasing at 20 miles per hour. So dz dt is 20 miles per hour. You can write mph, but I like the little fraction thing. Is anyone confused? We're okay right now, right? I'm just writing stuff from the top. Where did I come? Oh, because it said right here, determine with radar that the distance between them and the car is increasing at 20 miles per hour. If you're here, the only way you can do that is with a radar. You have to go across like that. A radar only goes in straight lines. A radar does not. Yeah, radar gun.
Okay, so
Yeah.
it's basically, so it can't go like across.
It cannot. The radar cannot. Yeah, radar. It's a straight shooter. It's a radar gun. What's up, Alvarez? DZDT. Anything else, guys? Okay. If the cruiser is moving at 60 miles per hour, so I'm going down. Guys, focus. So my dy dt is negative 60. Does everyone know why I put negative 60? Because in my model, this cruiser is going down. Does that make sense? If I would have drawn the model differently, maybe I would have written it going up. But because it says from the north he's approaching this right-angled intersection, he's going down. Are we okay, guys? All right. If the cruiser is moving at 6 miles at the instant measurement, what is the speed of the car? So we want to know dx dt. Question mark. Here's the hardest part. Do we have a model that can relate x with y with z? What's the name of that model? Pythagorean Theorem. Pythagorean Theorem is going to come out all the time. So here we go. X squared plus y squared equals z squared. Are we okay? That's the relation. And I'm going to take the derivative with respect to time. If I take a derivative with respect to time, I'll have dx dt, dy dt, and dz dt. Do you guys see that? So here we go. What's the derivative of x squared with respect to time? 2x dx dt plus 2y dy dt equals, perfect. Yes.
If it's, never mind.
Are we okay? Ask. Oh, Good question. All of these that I have, you see how I have dy dt already given at 60 miles per hour, and you see how I have dz dt already, and I want dx dt? All of them have a t on it. Because all of them have a t on it, I know that I have to take the derivative with respect to time. Does that make sense? All right, here we go, guys. I think it's easier to work from here because that's what I want to figure out dx dt. If you can see it, go ahead and cancel out the 2's. If you cannot see it, then leave it alone. What I mean by that is, I know some of you have your algebra skills a little better than others, and I'm not trying to throw shade. And if you see it, 2x dx dt plus y dy dt, you don't have to write this down, just listen, equals 2z dz dt. Oh yeah, I can cancel out those 2's if I divide by 2. If you see it, go ahead and cancel it. If you don't see it, leave it alone. I'm going to pretend you don't see it, and I'm going to leave it alone. Are we okay? All right, here we go. I'm going to insert what I have. 2 times what is my x value? 0.8 times dx dt, which I do not know. That's what I'm trying to figure out. Plus 2 times my y value, 0.6, times my dy dt, which is negative 60, equals 2. And I don't have my z, but I can get it, times my dz dt, which is 20. How do I get the z? Yeah. So on the side, you're going to go 0.6 squared plus 0.8 squared equals z squared. Oh, man. Z equals the square root of 0.6 squared plus 0.8 squared. I believe that's a 1. 0.64 plus 0.36 is 100. But we'll check it just in case. 0.6 squared plus 0.8 squared. And it's 1, and the square root of 1 is 1. So z is 1. That's what we're plugging in right here.
I have a question.
Yes.
The square root of like 1 how do you
We're going to be talking about related rates, so we're always going to say, yeah, it's always going to be positive. It's distance.
So the hypotenuse is also.
The hypotenuse is always positive. Always, no matter what. Because we don't have negative distance. Well, technically right now. But negative could also mean that we're moving to the left or something, you know? All right, so here we go. I'm going to go ahead and multiply this. I believe that's 1.6 dx dt plus, I want to say 3.6 times 2, but not confident there, is it? I'm just going to go 2 times, was it 6.6, right? Times negative 60. All right, 72. Oops. 72 equals 40. Oh, negative 72. Okay, now we're ready. Add the 72 to the 40. So 1.6 dx dt equals 72, 82, 92, 102, 112. Let me know if I made a mistake. And then finally divide by 1.6. So what's 112 divided by 1.6? Let's find out. 112, you're faster than me, miss. Divided by 1.6. Well, I'm actually slow because okay. 70. Miles, put your limits, per hour. That's how fast he's going. He's going pretty fast. He's going faster than the cruiser. So the cruiser needs to pick it up. You guys don't think this is cool? Yeah, well, we got to start with easy ones and then work our way up, right? No. You can have one. Just one. Because I want to keep the other two for me. If someone else wants another one. No, I don't want money, miss. All right, here we go. Example 4. For you future engineers, look at this question. A hot air balloon rising straight up from a level field is tracked by a rangefinder 500 feet from the liftoff point. At the moment the rangefinder's elevation angle is pi over 4. The angle is increasing at a rate of 0.14 radians per minute. How fast is the balloon rising at that moment? Isn't that a cool question?
This is also a range.
Yeah, it looks like it. Draw the ground.
Nice architecture.
And then draw a rocket. I mean, I'm sorry, a hot air balloon. I don't know why I thought rocket. I'm just going to put a balloon like that. That's my hot air balloon. It's my hot air balloon, guys. And then, let's see, where's the tracker? The tracker is right here. I'm going to put a black dot. Air balloon level field track field by a rangefinder 500 feet away. Okay, because from the liftoff point. Okay, this you can write 500 only because that is static. That's the only thing that is not changing. So what's not changing? This distance right here. I'll put it in green. 500 from that guy to that guy, and that's 500 feet. Well, it's definitely harmonic, that's for sure. Because it sounds like a swing. He's going up and down. Like the bolt's all rusted up there. Let it rain, let it rain. Okay. Are we still okay, guys? Now, this height, let's see. Is that what we're trying to look for? How fast is the balloon rising at that moment? This height, put H. And put right here, put theta. So here's what we know. What do we know? We know theta is pi over 4. Do not put pi over 4 in the picture because then you're making it static. And we know that d theta dt is 0.14 radians per minute. Rad per minute. Because it tells me. What do we want to know? We want to know dH dt. Question mark. Are we okay? All right. You can, if you want, try and calculate what this distance is. I'm going to call it z, but don't make life harder. You don't need to. Give me a relationship between theta, h, and 500. Tangent. Does everyone see that? Tangent is opposite over adjacent, so here we go. Tangent of theta is equal to opposite h over 500. Are we okay? In previous instances, I would actually say to just take the derivative immediately, but on this one, it looks like it would be easier to get the h by itself, so I'm going to multiply both sides by 500. So here's what we have. I'm going to write h first. I'm going to have h equals 500 tan theta. Are we okay, guys? All right, now I'm ready to take a derivative with respect to what? Time. So I write dH dt is equal to 500. What's the derivative of tan? Secant squared theta, and then what do I put next to it? The theta dt. Oh, you're good, miss. Don't apologize. You're done with calculus, guys. Everything else is just basic algebra and pre-cal. So here we go. Ready? dH dt is equal to 500 secant squared of pi over 4 times, what was the d theta dt? 0.14. Do you remember what secant squared of pi over 4 is? Well, let's see. Let's see if we know what secant of pi over 4 is. 2 over square root of 2, right? Square root of 2 over 2. And I'm going to square that sucker, and I'm going to multiply by 0.14. So let's see, 2 squared, so 500. And I know some of you can do this real quick. 2 squared is 4. Square root of 2 squared is 2. 4 divided by 2 is 2. So then I have 500 times 2, which is 1,000, and then times 0.14. So does that turn it into 140? I believe it does. And I need units. Feet per minute. No, feet per second. This is a hot air balloon. That's 140 feet per second would be ridiculous. But 140 feet per minute sounds a lot better. Always make sure that your answer makes sense. 140 feet per second. I don't know much about hot air balloons, but I know 140 feet in 1 second sounds like a lot to me. I've never seen a hot air balloon go fast. Do we understand what we're doing, guys? All right. All right. This one is going to be kind of tough because there's a lot of moving parts. But I'm going to show you. We're going to do one the hard way, and then we're going to do one maybe kind of easy, and it does require geometry. But don't worry. I'm going to go slow. I'm going to go as slow as I can, guys. Water runs into a conical tank, so that means it's a tank shaped like a what? No, that's a demerit. Don't yawn. 2 demerits. 3 demerits, and we're going to kick you out. Yes, I would never. YouTube, that's me kidding. The kid actually wants to be kicked out, but we're not going to kick her out. I'm kidding this. All right, here we go. Water runs into a conical tank at a rate of 9 cubic feet per minute. So what is this 9 cubic feet per minute? What is that? A tank shaped like a cone. You see them all the time. You guys aren't from the country, right? You see them all the time. You see them all the time out in the country for grains. You never seen it? How do you think they load the grains into the train? The train pulls up. There's a little fill here, and it just, yeah, conical tank. A funnel, a giant funnel. Man, guys, we're in Texas. I thought we would be familiar with, horses and tanks. Even San Antonio, we're kind of country-ish. All right, here we go. The tank stands point down, just like I drew it, because, how else would you be able to get some stuff out? And has a height of 10 feet and a base radius of 5. How fast is the water level rising when the water is 6 feet deep? Okay, let's start again. Let's start with the question. What is 9 cubic feet per minute? That's a D what? Don't know. No. Cubic feet. What is that? dV dt. That's how much volume is going at a certain moment. Are we clear with that? All right. So here, let's draw a picture. Yes.
So, why is it dV?
Because it's a rate. It's how much water is coming out.
But then wouldn't it be like the change in position of it is time not to change its velocity? Because that's how I think.
Cubic feet. That's volume. Cubic feet. Not feet per minute. Feet per minute would have been like velocity. How many feet you travel in a. This says cubic feet.
Like, oh, okay.
I have 9 cubic boxes coming out every minute.
Okay, yeah.
So here's my tank. And here's the water in the tank. Oh, you guys want me to use blue for water? Okay. The height of the tank stands point down and has a height of 10 feet and a base radius of 5. Okay. So for the height, you can put 10 here like so, because that is static. It's not moving. That height is 10, and the radius over here is always 5. Now let's see. What do we got in here? From the center here, this distance is R. That is changing. And this distance is H. That is changing. Does everyone understand what I got right now, guys? All right. So let's see what we need. Or let's see what we have. We know that how fast is the water level rising? 10 feet in the base radius. How fast is the water level rising when the water is 6 feet deep? Okay, we know the height is 6 feet. Do we know what R is? But we can figure it out.
Yeah.
Do you see proportional right triangles in there?
Yes.
Yeah, so look, in case you don't know what I'm talking about, you see this green triangle? That is proportional to this green triangle and dotted. Maybe I should put it in black. Do you see that dotted black triangle there? Those are proportional, guys. I don't know. I haven't figured it out yet. So let's see. Yes. 10 over 5 is equal to 6 over r. So r has to be 3. R equals 3. Do you see how we got it, guys? Okay. You could also do cross multiply divide. All right. I think that's all we need. Yeah, that's all we need. Well, we need more stuff. How fast is the water level rising? So they want dH dt, question mark. Here we go. Volume equals, what was my volume formula for a cone? Pi r squared h. I'm going to do product rule with the r squared h like that. The 1/3 pi is just a constant. So here we go. dV dt, I'm taking the derivative with respect to time, is equal to, I'm going to leave this as pi over 3 instead of 1/3 pi. Is that okay with you guys? First, r squared times the derivative of the second, dH dt, plus the second, h times the derivative of the first, 2r dr dt. Are we okay? All right, I'm going to fix it. So dV dt equals pi over 3. I'm just going to make it a little prettier. R squared dH dt plus 2, what comes first, h or r? 2rh, a, b, c, d, 2hr. 2hr dr dt. Not that it matters, but usually when it comes to variables, you want to put them in alphabetical order. But 2rh would have been the same, no big deal. All right, we need, so here's what, I'm going to stop right here, guys. We have, let's see what we do have. Do we have dV dt? Yes. Do we have the radius? Are we looking for dH dt? Okay, so we don't have that. Do we have h? Do we have r? Do we have dr dt? But we can get it. You guys ready? Remember this relationship that you guys had earlier? Cross multiply that sucker. So 10r equals 5 times 6, what's that, 30? Divide by 10, so r, don't. Turn that 6 into h. So now it becomes 10r equals 5h. There we go. That's what I want. Divide by 10. Divide by 10. R equals, I'm going to write it like this, guys. I'm going to write it as half h. Are we okay so far? All right. Remember that I wanted dr dt, right? So dr dt is equal to 1/2 dH dt. Does that make sense to you guys? All right. This is what I can either insert this, substitute it, and I can have everything in terms of dH dt, or I can plug in whenever. Yeah, no, let's substitute it. Cool or not cool? All right, so here we go. I'm going to write it one more time. dV dt equals pi over 3, bracket r squared dH dt. And then if I'm going to plug in 1/2 dH dt, what's going to happen to that 2? Cancels out. So plus hr dH dt. Is everyone okay? Now look at this. I have it. I have it. I don't have it. I have it. I have it. I don't have it. Can I solve now? Yeah. So let's see. Hook me up. So what is my dV dt? 9 equals pi over 3. Bracket, what's my r? With a 3? Yeah. 3 squared dH dt. We don't know what that is. Plus, what's my h? 6 times, again, 3 dH dt. Perfect. All right, guys. Now it just turns to algebra. 9 equals pi over 3, bracket 3 squared is 9, dH dt, plus 6 times 3, what's that, 18? dH dt. 18 plus 9 is 27. So 9 equals pi over 3, 27 dH dt. I'm going to come over here, guys. 3 goes into 27 how many times? So I have 9 equals 9 pi dh dt. And then to get dh dt by itself, divided by 9 pi. So 9 divided by 9 pi, the 9's cancel out. So I have 1 over pi, and give me units. Feet per minute. Cubic feet. No, feet. It's the height. Oh, was that hard? A little bit. You guys want to see an easier way? Do you remember this, Moreno? Oh. All right. You're going to see. Ready for the easy way, guys? So look how easy this is. Is there another way to do example 5? Of course. What was my volume? Pi over 3 r squared h. And they want dh dt, right? So if they want dh dt, what you want to do is get rid of that r. Didn't you tell me we had similar triangles over here? So didn't you tell me this expression right here? So if r equals half of h, that's what it equals, right? Half h. I can replace half h with r. And now look, volume equals pi over 3, parenthesis, I'm going to write it as h over 2, squared h. Are we still okay, guys? Have I confused anyone? Okay, when I square that, volume equals, look, I haven't taken a derivative yet, h squared over 4 times h. And then when I multiply h squared times h, that is going to be pi over 3, h cubed over 4. What's 3 times 4? So here's what I have. Pi over 12, h cubed. I'm just going to take a derivative, and I'll have dh dt real quick. Let's see if we get the same answer. dv dt equals 3 pi over 12. I'm going to reduce that in a little bit, don't worry. H squared dh dt. 3 over 12 reduces to what? So dv dt equals pi over 4. And let's plug in what h is. What was h again? 6 squared. And what was, dh dt is what I'm looking for. Times dh dt. Let's plug in my dv dt. So times dh dt. And I'm going to erase dv dt here and I'm going to plug in what it was. What was it? Was it 9? 9. So check it out. 9 equals 36 pi over 4 dh dt. Well, 4 goes into 36 how many times? So 9 equals 9 pi dh dt. And now I can just divide by 9 pi. And OMG, 9 divided by 9 pi. And the 9's cancel out. So dh dt equals 1 over pi feet per minute. Did we get the same answer? Which one do you think is easier? I think it's easier too. Isn't this cool? No, you would have gotten it. All it is geometry. Can you figure out similar triangles? Yes or no? All right. We have a handout to do, guys.